Example 9 says find the equation of the normal line. So again, here it has the words find the equation of the line. It has this new word here, normal, that we haven't seen before. But find the equation line again is all about how do I find slope. Okay? It's going to be normal to a curve. And the curve is y equals x plus 1 over x minus 2. And it passes through a point, 3, 4. That's called the point of normalcy. Since we're trying to find a normal line instead of the point of tangency, we're trying to find the point of tangent line. It's the same point. It doesn't matter. It depends on what we're trying to find. If we're trying to find a normal line, that's the point of normalcy. All right, going back here, how do we find slope? And again, I want to find the equation line. How do I find slope? I find the first derivative of the given function and substitute the x-coordinates value into the derivative to find the slope of the tangent line. Steps 1 and 2 are exactly the same. So whether it says tangent line or normal line, find the derivative, find the slope of the tangent line. The normal line is the perpendicular line to the tangent line. Okay, remember back in Algebra 1 and 2, find the equation line that is perpendicular to this function that passes through this point. This is the application of that technique. So, first derivative of the function gives me the slope of the tangent line formula. Substituting the x-coordinate value gets me the exact slope of the tangent line. And then I create the perpendicular slope by doing the opposite reciprocal. Once I know what the slope is, y equals mx plus b, substitute the point of normalcy in the slope, the normal slope in, and then you get your answer. All right? So, to apply that to this problem. Notice the function this time, y equals x plus 1 over x minus 2, is a quotient. It's a rational function. Okay, there's no way to simplify a rational function using algebra, usually. There might be some factoring possibilities, but x plus 1 over x minus 2 doesn't factor. So there's no way to avoid the quotient look to that, so the quotient rule is necessary. We have a bottom, which we call low, and we have a top, which we call high. And the quotient rule says that we do low d high minus high d low over the square of what's below. Okay, so just take a moment to digest this real quick. Low, which is bottom function, d high, derivative of top. The top is x plus 1, its derivative is 1. So low d high is just x minus 2 times 1. High d low, x plus 1 is the top, derivative of the bottom is 1, so times 1. Over the square of what's below, x minus 2, the quantity squared. If I simplify, x minus 2 times 1 is just x minus 2. Negative 1 times x plus 1 is minus x minus 1. That's for all this here. And again, there's always a minus sign here. There's almost always a distributive property going on here, so be careful. That minus is attached to this one that's being distributed through, so both those signs change. X minus x cancels, so I end up with y prime equals negative 3 over x minus 2, the quantity squared. Alright, so again, job 1 of find the normal line, equation of the normal line is find the derivative of the function. The derivative of the function is the slope formula for the tangent. So to find the tangent line, I've got my point 3 comma 4. So the slope of the tangent line, I'm going to put slope sub t. Maybe put some sort of a subscript there to really reinforce in my mind this is not what I'm looking for the purposes of my problem. It's what I need to find what I'm looking for. Okay, the slope of the tangent line, if I substitute x with the number 3, I'm going to get negative 3 over 3 minus 2, also known as 1 squared. That just equals negative 3, right? So steps 1 and 2 again are exactly the same whether I'm trying to find tangent or normal. Step 3 now, I need to create the normal slope. Put perpendicular m or m sub n for normal slope. Take your pick how you want to identify it, but again, make sure you have some kind of identifying mark in your paper so I know that you're going through the brain work necessary to realize that we're modifying this to find what we're actually looking for. The normal slope is going to be positive 1/3. We change the sign and we reciprocate. Reciprocal of 3 is 1/3. The negative sign changes to a positive sign. So at this point, my point of normalcy is 3 comma 4. My slope is 1/3. If I go to y equals mx plus b, substitute y with the number 4, m with the number 1/3, x with the number 3. 1/3 times 3 is equal to 1, which is nice and friendly. Doesn't have to be. Okay. 4 equals 1 plus b, so therefore b is equal to 3. I don't know how many of you are still doing this. I've still got Algebra 2 students doing this a lot. They'll put 1 over 1, or they'll put 3 over 3 there. Okay, hopefully you guys being calculus students, you've worked in fractions enough now that you're comfortable enough to say 1/3 times 3 is equal to 1. Once this is not a fraction, make it not a fraction. Life is easy when no fractions are around, right? So, again, 3 over 3 is not wrong, it's just not the best form of the number. So 1/3 times 3 equals 1. This happens a lot where the fractions go away. Let them, all right? If they don't, reduce the fraction as low as possible, get a common denominator over here to solve. Once I know the y-intercept is 3, and my slope again was 1/3, this is the slope I care about, this is the y-intercept I care about. Once I know this slope, all this stuff here is not of importance to me anymore. It's not going to help me get anything. Once I know what my normal slope is, everything over there is irrelevant to me. So, this is the structure of my answer, and I just substitute the slope and the y-intercept in. I'm going to get y equals 1/3 x plus 3. There's the equation of the normal line. If you were to graph that on your calculator, x plus 1 over x minus 2 would have some curvature to it. I'll give you a basic graph here because I don't have my calculator open. It's going to have a vertical asymptote too, right? X equals 2 makes it undefined. And let's see, if x is both positive, it's going to be positive, so it'll be like kind of like this here, and then probably like this here, and 3 comma 4 is over here, right? So if I were to plot this 1/3 x plus 3, it would form a right angle to a tangent line that we would have had. So the normal line should just go straight through at a right angle to the curve. All right, where the tangent line would be here. Well, that's not very good. Tangent line is there. The normal line should be perpendicular to the tangent line. All right. You're going to be asked to find either tangent or normal line. I don't think they ever ask you to find both. So in each problem that you see involving this skill, know which word means what. And I think also in this homework I might have given you a couple extra problems of the other types just to make sure you stay on top of things. Hopefully you'll find this to be pretty manageable.